So this one is pop quiz 9, which was related to electrolysis and energy change questions, enthalpy change or energy change. The diagram shows electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride, at which electrode hydrogen is produced. So how we identify? First, we have concentrated hydrochloric acid. So what are the ions present? So it contains H ion, Cl ion, H ion, and OH ion. For positive ion, we check the reactivity. Less reactive will move. So in this case, hydrogen is common. So hydrogen will move towards the cathode and there will be a hydrogen gas at cathode or electrode. And because it is a concentrated, so means it contains more Cl, so Cl will move there. So when two chloride ions are there, they will lose two electron and it will form a chlorine gas. So there will be chlorine gas. There will be a chlorine gas which will form at electrode 1, and on electrode 2 there will be a hydrogen gas. Same thing if we have aqueous sodium chloride, so it contains sodium ion, it contains chloride ion, it contains hydrogen ion and hydroxide ion. So less reactive will move. So hydrogen will move towards the electrode 4. So when hydrogen ions are there, they will take 2 electrons, it will form a hydrogen gas. And for negative ion, we check the amount. Sulfate, nitrate, and carbonate never move. In this case, we have concentrated aqueous sodium chloride. Because it's concentrated, so more Cl, so there will be chlorine gas at electrode 3. The question is, at which electrodes is a hydrogen produced? So hydrogen is produced at electrode 2 and electrode 4. That's why option D is the right answer. In question 2, aqueous copper 2 sulfate is electrolyzed using a copper electrode. Write an ionic equation for reaction at cathode. So what are the ions present in aqueous copper 2 sulfate? It contains copper 2 ion, it contains sulfate ion, and there is a hydrogen ion and hydroxide ion. So positive and negative electrodes are there, anode and cathode. And the electrodes are made from copper. So there's a copper here and this one is also copper. Now what will happen? The less reactive positive ion will move towards the cathode. So copper is less reactive, copper will move towards cathode. And this copper will move towards cathode. What is the equation? The copper ion, which is +2, it will take 2 electrons and it will form a copper atom. So it will stick to the cathode. Size of the cathode will increase. And to overcome this, the copper atom will go inside the solution as a copper ion. So copper atom turn into copper ion by loss of 2 electron at anode, and copper ions gain 2 electron to turn into copper atom. The question is, what is the ionic half equation for reaction at cathode? So at cathode, the copper ions gain 2 electron to form copper atom. That's why B is the right answer. Is it clear, this one? This was a pop quiz 9, which was related to the last week. Question 3 is a structure question. Bromine molecule, bromine monochloride is made by reaction between a bromine and a chlorine, and their bonds are shown. So calculate the total amount of energy required to break the bond in one molecule of Br2 and Cl2. So reactant side is a bond breaking side and the product side is a bond forming. So what are the bonds we are breaking? We are breaking bromine, bromine and chlorine, chlorine. And what are the bonds formed? Bromine and chlorine. And because there are these 2 here, so it means 2 molecules. So the bond breaking side is the reactant side and the bond forming side is the product side. So we write for bromine, bromine plus chlorine and chlorine. For bromine and bromine, it is 190, so we write 190. And for chlorine, chlorine, it is 242. So when we add them, we'll get 432. So this will be 432. That's a bond breaking. Calculate the total amount of energy released when 2 moles of BrCl are formed. Like when 2 moles or 2 molecules are there. So for each molecule, it is 218. So it will be 218 times 2. Or you can say BrCl and 2 molecules. So this will be 2 into 218. So when we multiply, it will be 418. So it will be 436. What is the overall energy change? How to get the overall energy change? Because this is a reactant side is a bond breaking side, product side is a bond forming side. If we need the energy change, the energy change is bond breaking minus bond forming. The bond breaking is 432 and bond forming is 436. So when we simplify, we'll get as minus 4 kilojoule per mole. And if you're getting a negative answer, this shows that this reaction is exothermic. So reactant side is a bond breaking side and the product side is a bond forming side. Is it clear, this one? So this was the pub quiz, which was related to electrolysis and the energy changes.